Defining the technological parameters is the next step in an iMachining 3D operation. Switch to the Technology page. In the Passes area, iMachining 3D enables you to specify the parameters used for calculation of the toolpath passes. By default, the wizard automatically calculates the optimal step-down values based on the tool information, lower level, and offsets defined for the operation. The value displayed in the step-down field defines the distance of each cutting pass, generating thick horizontal slices for roughing. Using proven iMachining 2D Technology Wizard algorithms, these roughing toolpaths are generated first with deep step-down passes. Rest roughing toolpaths are then generated in step-up mode to remove all rest material on sloped surfaces. By default, this step-up mode called Rest Rough is enabled in the operation and informs the iMachining 3D technology to generate thin horizontal slices for rest roughing, creating a staircase-like effect. The Scallop Parameter defines the distance to the peak of all steps on slopes that are measured perpendicularly from the machining surface offset. According to the local slope of each individual surface, the heights of the steps change dynamically in order to maintain the specified scallop size throughout the operation. By default, this value is automatically calculated based on the current tool diameter. However, an override checkbox is provided in the instance you would like to manually define the scallop value. Specifying a smaller value will result in finer passes. This can help to avoid semi-finishing operations, but the calculation time will be proportionately longer. For the purpose of this exercise, enable the override checkbox and enter a scallop value of 1.24 millimeters. Leave the default option of 30% for the scallop tolerance. This tolerance is an important parameter used for calculation of the iMachining 3D toolpath that is applied to the specified scallop value. The tolerance enables iMachining 3D to join two steps on two adjoining slopes, which would otherwise be cut at slightly different Z levels, and perform one long cut at the same Z level. This grouping together of toolpaths that fall within the specified tolerance increases the overall operation efficiency by shortening the total toolpath length and cycle time. There are two radio buttons for selecting the order between the roughing and rest roughing toolpath passes. For this operation, choose All Steps Down, then Rest Rough. With this method selected, the 2 steps down will be performed first, achieving the total depth, followed by the step-up rest roughing toolpaths. In the Offsets area, the default input values of the wall offset and floor offset parameters are 0.38 millimeters. For this example, let's enter a value of 0.24 millimeters for wall offset. By default, the floor offset will automatically default to the same value. The wall offset parameter defines the allowance that will remain on the machining surfaces, vertical and sloped, after the current operation is performed. The floor offset is applied to the tool and has the effect of lifting the tool along the tool axis, having its greatest effect on horizontal surfaces and no effect on vertical surfaces. Any remaining offsets can then be removed by subsequent finishing operations. In the morphing spiral factors area, leave the default positioning of the efficiency and entry rate sliders. In the cutting angles area, the angle and step-over ranges generated by the wizard are shown. In the tolerance area, iMachining 3D automatically defines the accuracy of the toolpath generation on the mathematical model. The value is calculated according to the current tool diameter. However, an override checkbox is provided in the instance you would like to specify a different toolpath tolerance. Note that a smaller value will result in less deviation from the mathematical model, but the calculation time will be proportionately longer. Switching to the link page, the helical entry settings do not apply to this particular geometry since it does not contain any closed pockets. iMachining 3D will enter and exit the cut where it calculates best. At this point, the operation can be calculated and the toolpath can be viewed on the model. Click the Save and Calculate button to add the iMachining 3D operation to the CAM tree and calculate the toolpath. After the calculation is completed, click the Simulate button to display the simulation control panel. Using the default HostCAD simulation mode, click the Play button to show the wireframe toolpath on the model. The tool approaches from the outside, moves around the part model, and performs the rough machining first with deep step-down passes. The rest roughing toolpath is then performed in step-up mode according to the specified scallop parameters. Now, switch to the Solid Verify tab and run the simulation again. Click the Play button. As the simulation runs, the solid model of the stock is dynamically updated by each cutting move. All air cutting is eliminated by the iMachining 3D technology knowing the exact shape of the remaining stock at every stage of the machining process, producing the highest level of optimized toolpath. Using the Exit buttons, close the Simulation Control Panel and the iMachining Operation dialog box. At this stage, Step 3 is complete. If you have not followed along, apply and practice the procedure shown in these videos to add an iMachining 3D operation to the CAM part and then define the rough and rest rough machining of the mold core.